here we're trying to solve for length EF, length EG, and length GF. So if we look at that, EF is this length right here. EG is the whole length, and GF is this piece. So if we try to do it all in the same order that it was put in, this one, then this one, we can find EF, we can find GE or EG, and then we can subtract. We can do this minus this to give us FG or GF. Again, those both are the same. So I'm going to start by finding EF. If I redraw this smaller triangle that uses EF over here, I've got 32 centimeters, 48 degrees, and this is EF, which is what we are solving for. We'll call that X. So anytime I've got a right triangle, the first thing I always do is I label where my hypotenuse is. My hypotenuse will always be across from that right angle. If you go from the bottom of the corner all the way up and across, that takes you to the hypotenuse. Now, they gave me 48 degrees. That is where my focus is. In terms of 48 degrees, X is right beside it. That makes X the adjacent side. And across from 48, if we have to go across the triangle, that will be my opposite side. So hypotenuse didn't have anything labeled for it. I labeled it just so I knew which side was the hypotenuse, but really I was only given variables or numbers for my adjacent and opposite sides. If I write out SOHCAHTOA, and I'm dealing with opposite and adjacent will be tangent. So I know that tangent of 48 degrees equals opposite, which is 32, over adjacent, which is X. So once you label your triangle, it's very simple to just plug and go. So I always label everything, and then from there I can just plug everything in. Because I do have a variable in my ratio or in my fraction, I need to cross multiply by putting tangent of 48 degrees over 1. I'm going to cross multiply. 32 times 1 is 32, and that's equal to X times tangent of 48 degrees. In order to undo that multiplication of X times tangent of 48, I really want my X term to be by itself. In order to do that, I need to divide, which is the opposite of multiplication, by tangent of 48 degrees. I'll do that on both sides of my equation to keep it balanced. Whatever you do to one side, you have to do the other. So these tangents are going to cancel each other out. Tangent over tangent is 1. So that's 1 times X, which is just X. So I get X equals 32 over tangent of 48 degrees. Now from there, because I have my variable on one side equal to something that has no variable, I can say X equals 32 divided by tangent of 48, and I get 28.812. If we're rounding to the 100th place is that second place. I'm going to look to the right at the third place. Since this is below 5, then this is going to stay the same. It won't drop down. It will never drop down. It'll just stay the same. It won't be bumped up. So X is equal to 28.81. What does X represent? It represents EF. So EF is 28.81. We were given the units, that's centimeters. Now, I'm going to solve for GE next. So GE is that long side. If I redraw my triangle, let me grab a sheet of paper real quick. If I redraw my larger triangle, that includes side length GE. This is G, this is E, this will be H. It tells me that EH is 32 centimeters. This is my right angle. It tells me this is 35 degrees, and I'm looking for GE, which will be my X or my variable. if I have been given this angle right here, that is my angle of focus. I'm going to start by labeling my hypotenuse. Going across from my right angle is my hypotenuse. Nothing is written there, so I will not be using the hypotenuse. I just labeled it so that I knew which one it was. In relation to 35 degrees, x is right beside it, making it my adjacent side. And across from that angle is my opposite side. So I have variables and numbers for my adjacent and opposite. If we're using SOHCAHTOA, then opposite and adjacent are used for tangent. So I know that tangent of 35 degrees equals opposite, which is 32, over my adjacent, which is x. I need to cross multiply in order to solve for that variable. So I'll put tangent of 35 over 1, and I'll cross multiply. 32 times 1 is 32. X times tangent of 35 looks like this. In order to undo my multiplication between these two pieces, I will need to divide by tangent of 35. But I can't just do that out of nowhere. I need to do that to both sides so that everything stays equal. Then these tangents are going to become 1. So we've got 1 times x, which is just x. So x equals 32 over tangent of 35 degrees. Plug that into my calculator. 32 divided by tangent of 35 degrees gives me 45.700. Hundredth place is this 0. If I look to the right, it's a 0, so this 0 stays the same. So I get 45.70. Now, it's asking me for the length of GF. So, if I found the length of, let me highlight it in a different color. I found this length right here. I found this whole length in pink. So I can do the whole pink length minus the red length to give me FG. So I can do the whole length is EG, which we know is 45.7, minus what we already know is 28.81, and we get 16.89. And this needs to be centimeters too. So that takes care of that one for us. If we're looking at number 4, let's get a little closer so we can see it. All right, for number 4 it says find the missing side length or missing leg of the triangle, then find the value of sine of A, cosine of B, and tangent of A. So anytime you're given a right triangle and you have 2 of the side lengths already, don't overthink it. We were not given any angle measures, so we can use the Pythagorean theorem. I'm just going to call BC x. Now, we need to remember the Pythagorean theorem is a squared plus b squared equals c squared. C will always be the hypotenuse. Remember, the hypotenuse will take place across from that right angle. So this must be C. From there, your A's and B's don't matter, because if A is 1 and B is 4, 1 plus 4 is 5, or if A was 4 and B was 1, 4 plus 1 is 5. When you're adding, it doesn't matter how you add things together. It'll still work out the same. So, if I have 12 and x, I'll just say that's A and that's B. Technically, this could be B and this could be A. Now, I will use the substitution property. If A is 12, I'll substitute that in and I'll say 12 squared plus B is x, so x squared, equals C squared, which is 13 squared. Now, sorry, 1 second. Okay. So now I'll use my calculator and I'll say 12 squared is 144 plus x squared equals 13 squared, which is 169. Now, in order to solve for x, I'm going to need to get x by itself. So I'm going to subtract 144 from both sides of my equal sign. And I'll do 169 minus 144, which will give me 25. So x squared equals 25. To solve for x, I'll take the square root of both sides. That means x will be equal to 5. So BC or CB has a length of 5. We were not given units, so 5 is fine. And just so I don't get confused, I'm going to erase this real quick so I don't have all these letters running around and we can see everything clearly. We just solved, and this is 5. Now, it says sine of A. We need to remember SOHCAHTOA. That helps us with our trig functions and ratios. So if they tell me sine of A, that means I'm looking at that angle right there. Oh, I'm sorry. Let me pull this over to the left. There we go. So if we're dealing sine of A, what I'm asking you for is the ratio that's associated with sine of A. So if I'm talking about angle A, sine is opposite and hypotenuse. We've already said that 13 is the hypotenuse, so I know that it's 13 will be in the denominator. Then I just need to figure out which side is opposite, because that'll go on top. If I'm talking about A, opposite of A is going to be 5. So that's all you need to do there. For cosine of B, now I'm talking about that angle right there in green. It wants cosine of B. So cosine is adjacent and hypotenuse. The hypotenuse will stay the same for everything. So my hypotenuse will be 13. That's in the denominator. Now, adjacent to this angle here, adjacent to this angle here is the side that's right beside it, which is going to be 5. We also learned the rule of complements. Sine of this angle will be equal to cosine of this angle. Cosine of this angle will be equal to sine of this angle. So if we see here, we've got sine and cosine and A and B. So that's why those are going to be the same answer. Now it's asking for tangent of A, so we're back to pink again. Tangent deals with opposite and adjacent. It has nothing to do with the hypotenuse. So if we're looking at angle A, opposite of angle A is 5. And adjacent to angle A, right beside angle A, is 12.